Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, Permutations 2. So given a collection of nums, that might contain duplicates, return all possible unique permutation in any order. Okay, so this is just permutation, and the obvious thing is that there are library functions that does this in multiple language. Not going to do that because if I do, then that's just like a really silly video and you'll be like, this is useless. But the idea here is also the tricky thing. Okay, let's start with the basic idea. The basic idea is just the n factorial way where it's just like recursive and you generate all possible permutations. The tricky thing here is that they're duplicate elements, and there are a couple ways you can handle those elements. The one thing to notice is that, and you could kind of guess what it is without looking, to be honest, is that it's 8 factorial is the worst case, which is only 40,000 cases, right? So you could definitely, for handling duplicates, you could definitely like do some kind of hashing and kind of look through it. That should be okay. 8 factorial is only about 40,000. And how do I know that? Like even while looking at the constraints, that I knew that this problem is going to be like on the order of n factorial, because you can't do better than that, right? That's the number of output, so that's going to be n factorial no matter what. And because I knew that, and because n factorial obviously grows very quickly, if n is any number that's big, it's just not going to run anyway. So like they have to make this small enough, right? So that's kind of the thing. The other thing to dedupe is just take one number at a time without so basically, instead of looking at them as distinct numbers, now you have buckets of numbers, and you want to take one out of each bucket at a time, where you merge the buckets of the same balls, if you want to call it that, where the two ones are together in one, and so forth. And that's the way let's do it that way, and that's the way I'm going to do it. This thing is up to from -10 to 10. Trying to think whether I should use the hash table. Yeah, let's just use the hash table so I don't have to think about it that much. And I could even use the collections.counter, but in this case, I want to be really precise, so that I'm going to use just a normal hash table. And implementation doesn't matter, so definitely experiment with it, figure out what it is that you think is good for you, and don't copy people's style. Use what is comfortable for you. That's what I would say. But I will actually convert this to a collection.default deck, so I don't have to check whether it's in there. I'm going to make it int, which default enters 0. And then now we have a generate all permutation thing. So let's get to it. How do I want to get to that? Okay, so let's just also n is equal to length of nums. So that's just, I'm just putting so I'm doing what I'm going to call bookkeeping. It's a term that it's not a name for an algorithm. It's just keeping track of stuff and making sure things, and certain ways in terms of implementation. If you keep track of certain things, it'll let you implement things easier, and that's what I'm doing now. And the thing is that you can calculate these on the fly all the time, but if you make sure some invariants are true, you can do this to kind of pass in the function, so that you have local variables that help you. And what I mean by that is that using length is equal to n, or n is equal to length, I could have something like recurse, and I could just have n left, right? And that's basically my thing. And maybe current array. And then okay, if n left is equal to 0, that means we're done. So do we have to keep them in sorted order, in any order? So we don't even have to do them in sorted order, though it's probably still a good idea. But if end up left, then answer dot append current array, a copy of the current array, and then we return. Otherwise, we go through the counts thing and just take it one at a time. And to be honest, I do actually have to make sure that this works, in the sense that, I mean, this will work, but I think sometimes when you modify stuff while in an iteration, it may give you certain issues in some languages. So I have to double check that. So n left -1, so that is just one smaller elements to kind of keep track of. We do this current array plus an extra element, which is the x. And this is just regular backtracking. I do actually have to keep track that if count sub x is greater than 0, so that we have 1 to take away. So we take 1 away from the count, we do a recursion, putting this element in the back, and then we add it back to the count. So that's pretty much it, I think. And then we could return answer at the end. We have to actually kick it off first, of course. So we use n to kick it off, and also an empty array. So let's give it a go. I'm just gonna keep the numbers small. I think these are probably good enough. Yeah, just to test them, because 8 factorial is going to print you a lot of stuff, so that's why I didn't choose a big number. But looks okay so far by eyeballing. You see that handling the dupe case as well, so that's the only thing that I had to double check. I am going to try an 8 thingy for a second, just to and in this case, to be honest, I'm very confident about it in terms of running time. But sometimes when you do things with a brute force, you know, you want to do the worst case just to make sure that it runs fast enough. And in this case, I took a look. I'm like, okay, this is good. And I look at this, and it's long, of course, because it's printing a lot of stuff, and it takes about 264 milliseconds, which should be okay, given that this is the worst case anyway. So I click submit. It's good. And yeah, so these are the things that I think about. In terms of complexity, like I said, the size of the output is going to be n factorial, so you can't really do better than that. It is output sensitive. Yeah, and that is both the time and space, because, well, that's the amount of space that we need for also outputting the results, right? So you can't really do better than literally giving the best answer that you can give. So yeah. That's all I have for this problem. Let me know what you think. I think the only thing that is tricky is that I do this bucketing thing to handle duplicates. And the reason why that works is that now when we go one at a time, we don't have to worry about the order. We just take the, because now it's indistinguishable which ball we take from a bucket, say, right? So now you don't have to worry about like ball 1, ball 2, and they have the same number in different directions, and that's how this invariant holds. And yeah, that's all I have. Let me know what you think. This should be a good problem for backtracking, for practicing. So definitely make sure you understand this, and harder backtracking problems will be you know, in your domain soon. Anyway, that's all I have. I'll see you tomorrow, and hit the like button and all those other buttons. Bye bye.